I'm hoping everybody can hear me and see me okay. Please let me know if I freeze or since we're having problems. I think the rain causes issues with the internet bandwidth. But good evening to everyone who joined us from India, and good morning to everyone from the United States who's able to join us for today's webinar. On behalf of the United States Agency for International Development, or USAID, I am delighted to welcome you to today's event to release the report, Preparing Distribution Utilities for the Future, Unlocking Demand-Side Management Potential, and the new tool known as EFFORT. I would especially like to welcome Mr. Sinha, Group CEO of BSES, and Mr. Bansal, CEO of BSES Rajdhani Limited, or BRPL. Climate change is a critical obstacle of our time, and the clock is ticking fast. USAID recognizes this global issue, and in India, we are working collaboratively with the government of India to address the root causes and effects of climate change. The climate crisis requires both our countries to act together and to act urgently. The government of India has demonstrated great commitment and leadership by setting a target of deploying 450 gigawatt of renewable energy by 2030. I want to congratulate the government of India and everybody working on this for achieving already the deployment of 98 gigawatts capacity. The US-India energy relationship is one of our most vibrant and successful partnerships. The US government is proud to support India in its clean energy transition. USAID in particular is proudly supporting India's effort to lower emissions, accelerate clean energy transition, expand the use of nature-based solutions to address climate change impacts, and support climate resilient communities. USAID is supporting India's transition to affordable and sustainable energy, which not only reduces emissions, but also spurs economic growth. The Greening the Grid program is an excellent example of the US-India partnership in energy. Over the past 5 years, the program successfully engaged with key stakeholders to support large-scale renewable energy integration through innovative pilots, regulatory support, peer-to-peer partnerships, and rigorous modeling exercises such as the one we're here to discuss today. Today's report and tool launch are significant milestones in our joint endeavor to further strengthen the US-India Strategic Clean Energy Partnership. USAID recognizes that the private sector plays a significant role in addressing India's development challenges. So I would especially like to thank our private sector partner, BRPL, for their participation in this work. While there has been a significant focus on identifying and demonstrating grid integration solutions on the supply side, there has been limited focus on increasing demand-side flexibility capabilities. As the report notes, demand-side management, or DSM, helps utilities reduce the demand of power during critical periods with limited power availability. This report illustrates the potential of DSM and how it can help utilities reduce their peak demand and unlock demand-side flexibility. As such, I am delighted to announce an open source tool named EFFORT, which was developed as part of this work. The Report and EFFORT tool will provide a strong foundation for Indian distribution utilities to adopt demand-side management as a measure for large-scale integration of renewable energy and manage peak demand. Over the next several months, we will share lessons learned from the study so that utilities from India and the South Asian region benefit from the findings. Before concluding, I would also like to thank and acknowledge Joint Secretary Nirayan, who unfortunately could not join us due to a last-minute meeting with the minister. He is very supportive of our work in the power sector, especially on the Greening the Grid program. I would also like to thank Mr. Sinha, Director and CEO of the BSES Group, and Mr. Bansal, CEO of BRPL, and his team, including Mr. Rajan, for their guidance, support, and active participation in these studies. Finally, I would like to congratulate the team from the National Renewable Energy Lab, who collaborated with the BRPL team in developing the report and the tool. I would also like to thank our implementing partner, Deloitte, for their work on the report and hosting this event. Thank you all for joining us today. I encourage everyone to take advantage of the vast expertise available here today, and I hope you have a very fruitful discussion. Thank you.
Thank you so much, Karen. And I apologize for the internet connections which I'm facing today, but Ripu would carry the show forward if I do drop off. So let me now move on with the next part of the program. We would like to invite our next speaker for the day, Mr. Sinha, Amal Sinha, who is the Group CEO, Director and Group CEO of BSES. Mr. Amal Sinha is a thought leader and a chartered and cost accountant with more than 33 years of rich experience. Since 2016, he has been working as the CEO of the largest private sector distribution company, BRPL, a joint venture between Reliance Infrastructure Limited and the Delhi government. In 2021, Mr. Sinha was given the responsibility of both BSES Rajdhani as well as BSES Yamuna as the Director and Group CEO of a BSES Delhi Power Distribution Business Limited. So I'm really delighted to invite you, Mr. Sinha, and also thank you for the collaboration and partnership which we had with BSES, both with the Yamuna as well as with the BRPL. So over to you for your special remarks.
Thank you, Manali, and thanks, Ms. Karen, for the opening remarks from your side. I thanks the USAID team, the NREL team, and Deloitte team, and above all, the support which we have received from Ministry of Power for making this report possible. I think it was a wonderful experience for BSES Rajdhani Power Limited to have involved in ourselves in this project, which is future. And this is what we are looking at, being a progressive power distribution utility and one of the largest in India. So far, the conventional distribution companies are supply side companies. We are basically looking at the supply side. But now demand side management becomes very, very important. And for a distribution utility, few things becomes very important, that we want to give an affordable tariff to our consumers, and therefore we need to not only control the supply side, but we need to control the demand side of the management, because if we don't control it, there is a huge investment which is required in maintaining a network if the demand is growing exponentially, particularly to service the peak demand. Secondly, the power management or the power scheduling and the power availability also becomes a huge challenge and task for a distribution utility. So for a company like us, it makes us a lot of commercial sense and technical opportunity also to educate our consumers, make them conscious of demand side, and gear them for the new things which are coming. And this project has given us some insight into it. And the good part is that the consumers are very happy. A large part of the consumers during the study we have approached, they have been very, very responsive. They want to be aware how they can control their demand. And this is something which we need to see how we can encash this, opportunity with the consumers. And I definitely quite sure that with the release of this report and experience worldwide, which we'll get from NREL and with the association of Deloitte, will help BSES Rajdhani Power Limited to meet this challenge, the demand challenge which we are foreseeing, particularly in Delhi. The demand is going up every year by almost 5 to 6%. So it is a big challenge for us, being a very, very highly densely populated city with hardly any space. So these operational challenges are there, and this is the opportunity for us. So I thank NREL and the entire team of Deloitte, and particularly support from USAID and Ministry of Power to have chosen BRPL for this initiative. And I wish all the very best for the report and future endeavors which we will do along with the team of NREL and USAID. Thank you so much, Monali.
Thank you so much, Mr. Sinha. We also are looking forward to working with BRPL, BSES in our future endeavors. Thank you so much. We'll now like to invite our next speaker, Mr. Rajesh Panson, CEO, BSES Rajdhani Power Limited. Mr. Panson is presently working as the CEO. He has over 10 years of experience in meter designing, manufacturing, and 17 years of experience in electric power distribution, and has shared his experience and knowledge at various forums and with number of power professionals and engineers across the globe. It gives me great pleasure to invite you, Mr. Bansal, for your special remarks. Over to you, sir.
Yeah, thank you, Monali. As a power distribution professional, I feel the business of power distribution is basically to ensure reliable, safe, and quality power to each consumer. When I say each, means each and every consumer, and to ensure that there is a efficiency and there is a reliability in the operation. Now, this word consumer demand is whatever quantity he wants, wherever he wants, and whatever time he wants. So the demand definition has also changed. It has three magnitudes: the quantity, the location, and the time. And the key to achieve that, to ensure the reliability, to ensure the efficiency, is the distribution companies has to manage their demand curve. And we at BRPL, which is one of the largest or the biggest power distribution company in terms of handling the peak demand, we are handling almost demand in the range of 3,200 megawatt plus. We are the one who appreciate and who understand this demand curve which is going up. I just share some of the data as our group CEO has said. Our demand is increasing at a rate of around 5.8% every year. And in fact, in summer 2017, the demand has gone up by almost 13%. 13% in 1 year. That means I should have, for every 8 assets, I should have 1 more asset. So that was the requirement what we had. And if we compare the load factor, which is the ratio of average demand and the peak demand, 20 years back, it was around 0.7, and now it is in the range of 0.48. So means we are investing, the infrastructure needs are going up because of the demand, but the MU sales are not proportionate to that. So definitely there is a big need for us, and my entire team is very eager to know about the recommendation, to know about the report, how we can address the issue of peak demands. In fact, North India and especially Delhi area, there is a big fluctuation in the demand. The demand varies a lot with the season, and you can imagine the top 10% of the demand, which is around 300 megawatt, if I say, is persist less than 100 hours, and in fact the top 100 megawatt persists not even for 5 hours in the year. And for that we have to invest a lot, and which affects our ARR, which affects the tariff. And the typical issue which we are facing, apart from the investment and making infrastructure thing, is big cities like Delhi, space is becoming another issue. So there is a big need that we have to address this surging demand, this galloping demand. The latest study which is done by the Delhi government and the town planners, this is the demand which is in the range today, Delhi demand, total Delhi demand, which is in the range of 7,400 megawatt, will go somewhere around 19,000 megawatt by 2041, means 20 years from now. 19,000 megawatt is a huge demand. So certainly we are eager, and I am thankful to NREL, USAID, Deloitte, and Ministry of Power for conducting such studies, and which will help us to curtail the demand and give the efficient service to our consumers, and that will enhance our reliability, address the constraints what we have. So this is all, and yes, my team is eagerly waiting for it. Thank you.
Thank you so much, Mr. Panson. And yes, thank you again to both you as well as Mr. Sinha for the partnership. And we look forward to collaborating in future. Now we are at the point where we would be doing a virtual release of the report as well as the tool. So do I have the permission, Karen, yours, Mr. Sinha and Mr. Bansal's permission to go ahead with the release?
Yeah,
Okay.
sure, Monali.
Thank you. So over to you, Ripu, for doing the honors. Please play the clipping. We wanted to do also a virtual, click kind of thing for the tool, but with the whole network challenges we are facing, we stuck to being conventional and just doing a snapshot release. But thank you so much to all the three dignitaries for joining us and giving us your remarks. We'll now move on to the second part of the program, which is the technical presentation by colleagues from National Renewable Energy Lab. We have with us Adarsh, Killian, as well as Kapil and Kapil, who will be making the presentation. Let me just quickly introduce them. I'll just give a brief introduction to the team. Dr. Adarsh Nagaraja is the Group Manager, Power System Design and Planning at NREL, and he primarily focuses on research on power system designs and planning in Power System Engineering Center, with the focus on advanced power system research relating to fast-changing energy system. He is the principal researcher and led all the three modeling studies which we did with BRPL. Joining him in the presentation is Dr. Killian McKenna, who is the senior engineer and principal investigator at NREL. And Dr. McKenna is an R&D 100 award-winning researcher at NREL, leading projects in the area of distributed energy resources. We also have Kapil Duawadi, and I'm sorry, Kapil, for mispronouncing, who is currently a research engineer in Grid Planning and Analysis Center at NREL. And all three of them will making a presentation on the tool, followed by another presentation by a colleague from GTG RISE. So I'll just pass on to you, Adarsh. Over to you.
Thanks.
Yeah,
Thanks.
Ritu, can you make me a presenter so I can share my screen?
Thanks. Yeah, it's such a pleasure to go after all the dignitaries. It was a big thanks to all of you for setting the context. It's the topic of demand side management, demand response, energy efficiency, as referred to in different parts of the world in different ways, is not the easiest topic. For example, if somebody has to buy electric vehicle, they can just go and buy, whereas demand side management is more complicated than all of that, because this involves a complicated tariff structure, then motivating a customer, and then again, as Mr. Bansal so rightly pointed out, the expectation is that distribution utilities are expected to provide cater to the demand as and when it goes. So it's a fairly complex research topic in general. We hope that our team here have put effort to streamline this topic and help BRPL to start with, and any other utility in India, to utilize these solutions or knowledge that we have put together along with the GTG RISE team to look at demand side management and make the best estimation they can out of enabling what can they even get out of it. Go to the next slide. Let me start with the team here. Without the team, nothing can be done. We were so lucky to have this enthusiastic a team. Let's start with the utility itself. BRPL is such an enthusiastic partner to work with. A big thanks to Mr. Avinash Kumar. I think he's in the attendees. I saw his name. Thanks to you, and thanks to Abhishek for constant support. We kept going back and asking for clarity, data support again and again and again, and not a single day there was a delay. They were on top of it. They were helping us achieve what we should achieve. Big thanks to BRPL team, kudos. And GDG RISE team. Let me clarify one point here. This particular effort, excuse me from my throat here. This particular effort, we had a opportunity to work with GDG RISE team, which included working with Mr. Jayanta Bora and Mr. Krishnakant Gupta. Mr. Jayanta will be talking today along with us. This particular topic of demand side management involves customer behavior, customer motivation. So if you all remember the timing of this project, we were working on this project at the peak of COVID. So that was a whole another challenge and safety we were working with. So we took extreme help from GDG RISE team in a very strategic way, where we surveyed up to few hundred customers of different categories, residential, commercial, and who not, to understand what motivates customers and what sort of rate structures, tariff structures can actually see value from. And NREL team, last but not the least, they were integral. Here you will hear from few of them, which is Killian, McKenna, and Kapil Dwadi. But they were amazing support from other researchers like Shibani and David Patrick as well. So this is a great team we had. This particular work that we did, I take great pleasure in introducing this work. Next slide, please. So let me set the context. The leadership team here did an amazing job, starting from Karen to Mr. Sinha to Mr. Bansal, the amazing job, but still, let me set the context. Not long ago, customers decided the generation. I think that's a clear statement there itself. Like it was expected that generation should fulfill whatever the consumption was. But then the present is a bit different. Let's go to the next slide. It's the rest of the world, or most part of the states in USA, even in my home, I personally have signed up for a rate structure where I cut down peak generated consumption. What happens what's the benefit of doing it at all? Why should utilities even manage customers' demand, consumers' demand to start with? And what are the benefits? What's the cost to even enable it? And so many questions. What should be the rate structure? What should be the peak pricing to off-peak pricing ratio? It's like you want to start where? And that's why we are calling this study Unlocking Demand Side Potential. Here we are to help unlock that potential. It's not a one-step change you do and everything changes by itself. It's like many small steps one should take to help this happen. But there are certainly benefits that BRPL and other utilities who choose to do this can take advantage of. That's where we are here to help and provide support. Next slide. So let me also go one quick slide and say, what are the benefits of demand side management at all for discoms or distribution utilities, as we want to call them? Peak load is certainly the point. Mr. Bansal rightly pointed out, BRPL is so lucky to have leadership team like as knowledgeable as them, right? So right, peak load. Peak load happens so few hours in a year, whereas the infrastructure is built for that peak load or even exceeding the peak load. In BRPL, peak load happens for the first few percent of peak load happens for 8 hours in a year, which is very minimal. Even if BRPL can encourage customers to manage their peak load, it's a cluster. Every homeowner, not every, even a small percentage of homeowner choosing to reduce their consumption by a tiny bit adds up to a huge number in the end of the day. What happens is because of all the responsible behavior, utilities can expect operational benefit economic benefits, and at the end of the day, customers will be responsible and they feel happy that they are contributing to the betterment of society at the end of the day. So it's a circular loop that we all go through. These are the benefits, but how to walk from present to where should we be? And that's the rest of the slide deck we'll be talking about. There's a very well written report available for you all. I will put the report link anytime here. Please take a minute to read that. In the meanwhile, I will pass over the slide deck to Dr. Killian McKenna and Kapil Dwadi, who will be running along with Mr. Jayanta, who will be sharing some very interesting insights on customer survey that we got from BRPL customers. On to you, Killian.
Great, thanks Adarsh. And again, thank you to everyone who participated in the study and all of the collaboration. It was a really fruitful effort, and we got some great insights, and we're able to do some really great work here due to that collaboration. Adarsh talked about some of the benefits of demand-side management in terms of unlocking demand-side flexibility in order to improve the efficiency of the grid in terms of both reducing energy consumption and making customers more aware of their consumption patterns, and also trying to shift consumption away from the peak hours. There are many different forms of demand-side management, and there are different ways of implementing them, and all of them should be for the customers that you're working towards. So you need an insight into, what is the consumption patterns for the utility that we're working with? What are the demographics of those customers? What are the different customer classes? And that's the first thing that we wanted to understand in this project. We wanted to try tailor demand-side management to BRPL and their service territory and their customers as much as we could. And the first way to do that was to get as much information on those customers and their preferences and the way that they consume electricity as we could. And that was where this collaboration with BRPL and the G2G RISE team was absolutely essential and really provided a lot of fruitful information. So the first thing we wanted to understand was the readiness of customers. So understand in BRPL's service territory, what's the percentage of residential and commercial customers? What kind of characteristics do those customers have? What are their consumption patterns? What are their local needs? What energy consumption in terms of end uses do they think are essential? And what end uses, if they're talking about heating or cooling or cooking, do they think they could be more flexible with? Because then we could start tailoring this demand-side management program to those and trying to understand that customer knowledge. And, are customers interested in environmental impacts of energy consumption? Are they interested in energy efficiency? Are they even aware of their consumption patterns? That was a really important first piece to understand. And Mr. Jayanta will be presenting some really great information that we got from the survey on that side. So understanding the readiness of customers was one side. The other side was looking at rate structure design. So because in BRPL service territory, the majority of the customers are residential, we really wanted to focus on, are there rate structures that could help kind of motivate customers to shift consumption away from peak hours and provide this flexibility and provide this efficiency in terms of operating the network that really benefits everyone. It benefits the utility and benefits the customers in terms of delivering electricity more efficiently. There we wanted to look at the duration of peak hours. When do they fall? What are the seasonality impacts? What kind of level of incentive in terms of on and off peak price ratios would need to be provided? What kind of benefits do we get from this response? What are the benefits in terms of reducing the amount of network upgrades that might be needed? What are the benefits in terms of reducing the use of peaking generation that's more expensive? And then we also wanted to start thinking about, like, what is the readiness of potentially trying to implement some of this, and what would the next steps be if we find a time-of-use rate structure that could be beneficial for residential customers? How would you go about implementing that? What would be the barriers for that? The kind of key takeaways for this entire study and the report is really, again, it's unlocking that demand-side management potential and understanding the voice of the customers. We developed this reusable framework called EFFORT, which is the effectiveness of rate structures, and to really help analyze, how can you start developing time-of-use rate structures? How can you get those benefits? We wanted to understand the sensitivity of the on-peak duration. So if we go for more hours of the on-peak period, and if we go for greater price ratios, how might customers respond? And really what we found was that time of use has the potential to reduce peak demand up to 4% of the 3 gigawatt peak for BRPL, which is really a good potential benefit that you can achieve from implementing time of use rate structures. But there's also ancillary benefits that utilities see over time, not just in terms of reducing peak demand, but also in terms of making customers more conscious of their energy consumption and trying to be more efficient. For the voice of the customers, we really got some great information on this. We developed this comprehensive survey structure, with over 90 questions for both domestic and then commercial and industrial customers, surveying over 400 residential, we'll refer to as domestic from here on, and then over 300 commercial customers. So as I was kind of talking about, the first part in the study was understanding the background of BRPL for their customer classes and getting the voices of customers from this kind of comprehensive survey. So there's two parts to this. We'll first talk about some of the load consumption patterns, and then I'll hand over to Mr. Jayanta for the survey piece. This is probably common knowledge to a lot of the BRPL folks on the call. But really, we wanted to first of all look at the seasonal energy consumption patterns, and a lot of people alluded to this earlier, right? That there is this seasonal, very evident patterns in consumption, and that's what you're seeing on this graph on the right-hand side. In terms of looking at the total load consumption in BRPL service territories, we saw this kind of summer and this winter demand profile. In summer, we saw this kind of this dual kind of peaking, but with this kind of larger peak in the late evening. And then the winter day, we also saw kind of a dual peaking period. So there's this kind of idea that maybe looking at a 1 or 2 on-peak tariff period might be beneficial for the utility, and trying to identify what hours would those on-peak periods occur. And then, what is the magnitude of peak demand? So a lot of folks talked about that earlier in terms of, if you look at the duration, and we'll show that in the next slide for when peak demand occurs and how much it's utilized, you're getting a lot of network capacity and a lot of generation capacity that are used for a very small amount of the time, which means that essentially the consumers are paying for a lot of capacity and a lot of generation that is utilized very small amount of the time, which is costly to everyone. But unless you start providing demand-side management, you're not giving that signal for customers that they can change their behavior to try and improve the efficiency for everyone. We looked at the energy contribution by sector, and that's where 67% of BRPL's annual energy consumption comes from residential, 31% for commercial, and 2% for industrial. And there is a time of day tariff right now for commercial and industrial customers in BRPL service territory, but not for residential. So that was part of our focus here. So as we've kind of talked about this, this idea of peak demand and customers kind of having similar consumption patterns so that they're all consuming at the same time does lead to this ineffective utilization of infrastructure. And it's not just the demand profiles, it's that, there'll be relatively few days in the year where you're using a lot of capacity for a very small amount of time. So if we look at like this kind of looking at like the 10% of these peak out load hours. So essentially this graph is ordering the consumption from the highest all the way to the lowest. So we get a duration of, when each of these levels of consumption are utilized, right? So if we look at 10% of the year, so that's 10% of the total capacity that is required only occurs for 1.45% of the time. So at this top left-hand side of the curve, you're really seeing that exponential use of you need more and more capacity for fewer and fewer amounts of time. And essentially what this demand-side management potential is trying to reduce that steepness of the curve so that you're alleviating a lot of that, low utilization capacity to try save both the utility and the customers on that low utilization of capacity. And BRPL estimates an annual savings of 2 crore rupees per megawatt hour for peak load reduction, which is definitely something that is significant. So that was the load consumption characteristics. I'm now going to hand over to Mr. Jayanta, who will present about the domestic and the commercial survey results to kind of give you an insight of how customers feel about demand-side management.
Yeah.
Mr. Jayanta?
Thank you, Gillian. I'm Jayanta. Hello, everyone. So I'll be taking you to the findings which we got from the domestic consumer survey. So overview is overall we surveyed around 413 domestic consumers during the period of June to July 2020. And each survey, each consumer was asked questions on about 100 different data points. And the survey sample consisted of around 73% male consumers and 24.9% female. And we found that most of them had they stay in their apartments and when household occupancy was around 2 to 4 people per household. And we could see that almost 74% of the respondents were either employed or retired, means they had a good economic status. And then we saw that around 89% of the people stay in their own house, means it shows the economic status of the entire sample. And it actually reflects the nature of consumption which we expect from these kind of consumers. So can we go to the next slide? Yeah, we'll talk about the key takeaway from these. We asked the consumers on their willingness to participate on various incentive programs. So we asked various questions to them. So we asked like one question that where are you, if the electricity utility was willing to pay you to change your electricity consumption patterns, how likely you will be likely to change make the following changes. So almost like 97% of the people, they agreed that they will reduce their energy consumption and use more green energy to help reduce the air pollution. And similarly, 96% people were showing interest in using less electricity consumption to reduce their bill and save energy and save money in fact. And 95% people were inclined to change to energy efficient light bulbs, whereas 78% people agreed that they will stop doing laundry during evening hours, and which again this percentage it reduces in the next few questions. Like in 75% people agreed that they will be inclined to increase their AC temperature settings during summer evenings, and 61% people were agreeing that they will turn off their AC during summer evenings, and 50% people said that they are willing to turn off their water heater during winter mornings. So we see that means there is an inclination towards participating in similar programs. So we will see much insight in the next slide. Yeah, so here we asked very specific questions related to their behavior in peak hour and off-peak hour. So we asked that if you had an opportunity that you have 40% lower electricity price during off-peak hour, what will you do? So these three questions, like 87% of the people, they will change to energy efficient air conditioning systems. And 68% people agreed that they will cook later or earlier in case of electric cooking. And 66% people said that they heating load during off-peak hours in the winter, like say between night 12 to 4 a.m. during November to March period, they are willing to change to change the heating load in that period. Similarly, we asked that in peak hours, means if the electricity price during peak hours during the daytime, say 2 p.m. to 5 p.m. and between 10 p.m. to 1 a.m. in the and in the night, it was 40% more expensive. How likely would you be interested to reduce or move your electricity consumption? So 66% they said they will respond to changing their cooling load, and similarly 66% said that their electric cooking will be changing, and 62% agreed that they will change their lighting load during those periods. The next slide, please. Yeah, so the main key question here was the AC load, which comes during the summer peak hours, which we saw from the previous slides. So we asked that if the utility was willing to pay you to turn off your air conditioning unit for 2 hours during the evening, like 8 p.m. to 1 a.m. in the summer season, what is the lowest monthly payment would you be willing to make for this monthly decrease in power consumption? Like they say, most of the people, they have agreed that 68% of the sample, they agreed to and alter their behavior to match the economics. And whereas consumers, we saw that consumers having 3 or more ACs do not show any preference towards getting these kind of incentives. We can see that almost 28% people say that they are willing to take an incentive of around 250 to 400 rupees in a monthly bill. Yeah. Next slide, please. So I'll summarize the domestic consumers survey. What we found that the demand peaks in the summer, which is driven by AC loads, which we could see from the previous slide itself. And consumers are interested in reducing their energy consumption. Like we saw that almost like 95% consumers are interested in reducing their energy consumption for both environmental and to achieve savings. And consumers are willing to change their behavior to reduce demand. We could see that there are some the consumers have shown some inclinations to reduce their demand and change their consumption pattern. And we could also see that consumers will respond to an increase in peak prices, like in 40%. If we could say that for a 40% reduction in peak during peak hours, 60% would cook. They have changed. They have said that they will change the cooking behavior. And then we have also seen that consumers are interested in transitioning to EVs. Like 60% of the consumers indicated some willingness to adopt rooftop solar, and 25% of the consumers are willing to become an EV consumer, EV user rather. So with that, we'll start with the next section of the survey, which we did on the commercial and industrial consumers. So here we surveyed around 318 consumers, and of this, 96% were SIP consumers, and 43% have connected load between 1 to 10 kilowatt. And we could see that the consumer profile, most of the businesses are in the range from 1,000 square feet to 5,000 square feet area. So, and around 73% of the respondents is up to 20 employees, and 40% of the respondents are business owners itself. So we could get their actual view from the owners itself. So, next slide. So here we asked the intent of the CNI consumers for participating in energy efficiency and DSM measures. We could see that most of them have agreed in reducing energy consumption, and they know that it is important to protect the environment, and they have also agreed that they should be active in reducing energy consumption and using energy efficient appliances. They are also inclined, whereas this agreement reduces a bit when we ask about green energy sources, and then they also agree that reducing their energy consumption and using more green energy will help them to reduce air pollution, and they are showing a lot of interest in to use less electricity to save the electricity bill and save money. So they have the intent, and they know that their consumption can drive pollution, and it impacts the environment. Yeah. Next slide. So here we asked some of the questions like whether you are willing to change some behavior. Whereas most of the consumers have said that they are not inclined to change the operation of some of the business activities. Maybe they are constrained by other environmental or external factors. Whereas most of them have agreed to change to energy efficient light bulbs and energy efficient air conditioning systems, and they are not willing to change the schedule of some of the energy intensive activities, because maybe it is linked to labor availability or the areas they work in. So besides changing their behavior, changing their operational pattern, they are willing to adopt new or efficient equipment. So we asked if your electricity, similar questions we asked to the CNI consumers also, that if your electricity price during peak was more responsive, what would you do? They are saying that they are means they are not willing to change the cooling load, whereas heating load they are not willing to change during the peak hour, but the change of business activity is also not at all likely. And if you had an opportunity to have we asked another question, that if you had an opportunity to have for 40% lower electricity price during off-peak hours, what will you do? So most of them would agree that they will change the cooling load during night time, and then they will change the other behavior, means change of other business activities, and electrical consumption is not at all likely. Means they are not willing to change the business pattern, but they are willing to change some of the activities, some of the shifting of the load. Yeah. Next. So our key observations from the commercial load survey are that they have high summer load, but their peak during October may be due to the festival season, and the cooling loads are not as prevalent, and many consumers have backup diesel generators. Like 30% of the respondents have said that they have cooling loads on the premises, and 92% have no heating loads on the premises. Whereas 69% of the consumers respondents have said that they have backup generators on their premises. Customers are interested in reducing energy consumption. Like more than 80% of the consumers are willing to reduce energy consumption to protect the environment, and they believe that they should use more energy efficient appliances, and they're interested to participate in energy efficiency, and they would like to see reduction in the energy bills, monthly energy bills. However, the consumers are not willing to change their consumption behavior. Only 58% of the respondents are willing to modify cooling use during on peak hours, and only 22% of the respondents were willing to change the operation of some of the business activities. With that, my slides ended. Yeah.
Great. Thank you,
Others,
Mr. Jayanta.
Yeah.
Thank you, Jayanta. And sorry to interrupt. I just quickly wanted to welcome Mrityunjay ji, Joint Secretary, Ministry of Power. Hello, sir. So we cannot.
Yes. Are you able to hear me?
Yes, we can hear you. Thank you so much for joining. And we went ahead with the program in the sense that we released the report and the tool, but we would really look forward to hearing you deliver the keynote address. Would it be appropriate to do it now, sir?
I think it's fine with me. As you wish.
Okay. If you don't mind, Adarsh, can we just go ahead and do the keynote address, and then we can come back to it? It would be good to hear Mr. Narayan, and then also Mr. Narayan to get a understanding on the analysis framework which has been developed. So over to you, sir.
Thank you, Monali. First of all, I apologize for being late. In fact, I wanted to join in time, but yesterday only one very high-level meeting got fixed, which I had to attend, and that meeting just now got over. So I'm here after that meeting. Good evening, ladies and gentlemen. I'm extremely happy to be here with you today. Today for report release and tool launch under Greening the Grid program, which is a joint initiative of USAID and Ministry of Power, Government of India. And I would like to congratulate Ms. Karan and USAID team, Mr. Amal Sinha, Mr. Rajesh Panson and BRPL team for their efforts in carrying out this important study and development of an open source tool. One of the key mandates of Government of India is to transition to a clean energy to cater to future energy needs in more sustainable and responsible manner while meeting its global commitment towards climate action. The Government of India is promoting greater use of renewable energy in the energy mix, but at the same time making an effort to efficiently use energy on the demand side through various innovative policy measures under the overall ambit of Energy Conservation Act 2001. With such large-scale penetration of renewable energy in India, it requires entire power system to be more evolved and balanced, addressing any demand-supply mismatch in real time is of utmost importance to ensure grid reliability. We need to investigate the full spectrum of solutions to support the clean energy transition, including electricity market products, solutions such as batteries and green hydrogen, energy efficiency, demand-side management, and much more. DSM is one of the major interventions world over that has helped utilities to achieve reduction in the peak demands and therefore high investment in their networks. It has also proven to be a reliable tool for system operators to balance intermittent generation due to solar or wind. Recently, last week only, Government of India sanctioned a revamped distribution scheme, a reform-based and result-linked scheme with the object of improving the quality and reliability of power supply to consumers through a financially sustainable and operationally efficient distribution sector. The scheme looks into both the upgradation of the distribution infrastructure and capacity building. Advanced ICT technologies would be leveraged to enable the DISCOMs to be able to take informed decisions on loss reduction, demand forecasting, asset management, time of day tariff, renewable energy integration, and for other predictive analysis. The study and the open source tool are therefore very timely. It's very useful. They will certainly contribute significantly towards implementation of the scheme for enhancing efficiency and financial sustainability of DISCOMs. The open source tool effort, it has been aptly named, will enable more distribution utility to implement demand-side management projects by designing tariff structures that will motivate its customer to reduce its peak electricity consumption. Once again, I congratulate Ms. Karan and her team for their stupendous work. I strongly believe that these collaborative efforts supported by USAID will continue and help the Indian power sector to grow progressively, wherein the grid is more flexible, reliable, and efficient to foster and support renewable energy integration. I am sure our already strong US-India clean energy partnership will reach greater heights in future with these initiatives. I would like to congratulate Mr. Sinha, Mr. Bansal and his team for their proactive activeness and leadership in collaborating for this excellent modeling study, which would have relevance for all the Indian utilities. Finally, I would like to thank team for GTG RISE initiative for their efforts in conducting this important study to evaluate DSM and support DISCOMs to understand possible customer participation in designing an effective DSM program. I will also make a request to your team to continue supporting us and also in disseminating more information about the tool so that more utilities are aware of it and use it. Thank you, all of you. And lastly, I must thank for inviting me here and giving me opportunity to make some comments. Thank you very much, Monali. Thank you, everybody.
Thank you so much, Mrityunjay. Thank you so much for joining despite your busy schedule. Really appreciate it, as you have been one of the big supporters of USAID's efforts in the power sector. And I'm sorry to all the attendees for interrupting the presentation, but if we could quickly take a video or a photo of everyone, and can I request Mr. Sinha, if he's there, and Mr. Bansal, to please switch on your cameras and we can take a quick photo before turning it back to NREL team to continue the presentation. Dr. Killian was making a presentation along with Jayanta. Great. I think Bhupi, please, David, if you can switch on your cameras and please take the picture. Thank you. Thank you.
We're good.
Done?
Yeah.
Okay, thank you so much. And thanks, Karen. Thanks, Mrityunjay ji. And thank you, Rajesh ji, Bansal ji, and Mr. Sinha. Okay. Now, thank you. I'll turn it back to Dr. Killian to continue his presentation. And thanks once again to Mrityunjay ji for joining us. Sir, if you can stay on and listen to we are just about to go and demonstrate the model. We've shared some amount of results of the consumer survey, but if you can, that would be really great. But over to you, Dr. Killian.
Great.
Thanks,
Thank you,
Monali.
Monali.
Before we move on, there's a question that I want to bring up to Jayanta. Hope that's okay with you. One of the data points that we showed from survey mentions that consumers are ready or more interested in or okay with deferring cooking and heating during peak periods. Mr. Sitapati is asking, like, is that looks interesting. Like, do we need more validation on that, or how do we read that data or feedback we got?
I think this was related to electric cooking. So the consumers, we have asked specifically on electric cooking, not on gas. So I think this question refers to that only.
Correct. Yeah, no, that makes sense. Feel free to come and answer in the panelist chat if you have more insights on the question.
Yeah, sure.
And Keaton, I have a question for you before we move on. This is something I felt we should maybe have clarified sooner itself. It's a question from Mr. Oriana from South America, Chile, if I'm pronouncing the name of the country right. Question is about energy efficiency and demand side management. How similar are they and how different are they? Can you give a 2-minute on the aspects of them?
Yeah, absolutely. So demand side management should motivate both a change in consumption patterns, which utilities will see in terms of shifting demand from on-peak periods to off-peak periods if they start implementing, say, a time of use or time of day price. Energy efficiency also starts to appear through demand side management, like the utilities who've rolled out time of day or time of use tariffs actually see benefits on both. And the reasons that they start seeing benefits on energy efficiency is because time of day or time of use tariffs start to make customers more aware of their energy consumption patterns and more aware of, okay, if I start changing my patterns or if I start moving to more efficient appliances, I can actually save money in terms of reducing my bills. And also, when you start to roll out time of use or time of day tariffs, you start to provide customers with more information on, what consumption patterns drive energy consumption, which a lot of customers won't have good information on that. Like what activities that they're performing at home are intensive in terms of electricity usage, and what can they change in order to achieve that reduction. So energy efficiency falls under demand side management, but the type of programs that we're looking at here actually motivates that kind of shifting and also that reduction in energy consumption.
That's good. Thank you. Feel free to take a look at that question and have that answered. And thanks to Mr. Soni for putting the link from POSOCO on seasonality analysis and load factor for Indian power systems. It's a great link. I was clicking on that link like a few minutes ago. It's fairly informative. And there's one more question which I will answer once Kapil is done. I see that's a relevance to the effort tool there. So if that's okay with you, we can go with the framework and the key findings we have from the framework. Thank you.
That is, hi everybody, can you hear me first?
Yep, we can hear you, Couple.
Cool. Thank you, Gillian. So thank you for joining us today. So I will be presenting about the effort tool, how it works, and how we applied this tool to estimate the time of use price for BRPL. And before we go into the detail, let me give you a brief background on customer behavior and tariff a little bit, and we'll go into the detail. Can we go to the next slide, please? So the first step in designing the time of use tariff is understanding how customers behave when the price of electricity changes, right? So like other commercial commodities, electricity demand is also inversely proportional to the price. High price tend to motivate customers to lower the demand, and lower price tend to motivate the customers to increase their consumption. Now, utility can leverage this behavior in designing time of use tariff. By understanding at which time of the day peak occurs, utility can increase the price at those hours and keep the price low during off-peak hours. However, not all customers behave in the same way. Highly responsive customers tend to change their demand by greater amount for a given price change. And the ratio of a percentage demand change over percentage price change is also referred to as a price elasticity of customers. You might hear me switching between level of responsiveness and the elasticity during this presentation, but both of them mean the same thing. Now, customers' behavior to price change has two aspects to it. One is how much demand they will sift, and another is for how long they will sift, right? Some customers might change demand earlier by anticipating future price change, whereas some might postpone their demand and some might do both. So there is a combination of that. So flexible customers change their demand over a longer period of time for a given price change than compared to the inflexible customers. Now that we understand terminologies, let's dive into the framework that NREL developed called Effort for TOU Design and the key results. Can we go to the next slide, please? So let's talk a little bit about data inputs for the Effort tool. What you need is basically a time series load profile at the system level, right? On peak hours to be used to design the tariff, and information about generators, such as cost and capacity of dispatchable generators. The framework takes these inputs, the time series load profile, the cost information about the dispatchable generators on peak hours, all of this, and performs a optimization to estimate the time of use tariff. Using this framework, you can figure out what should be the ratio between on-peak and off-peak prices, and also the quantity of the peak reduction as well as saving. Now, when I say saving and the quantity of peak reduction, it is all dependent on the input that you give to the Effort tool. So if you give the right input, you might get the right output. But if your input is not accurate, then your output will also be not that accurate. So this framework can be used to also estimate seasonal tariff. Can we go to the next slide, please? Okay, so this framework can also be used to estimate seasonal tariffs. In order to do so, users need to define a number of seasons in the year and analyze load profile to come up with on-peak hours for each season. Now, there is also a built-in algorithm that takes in the time series load profile and gives you on-peak hours for different seasons. For example, we can separate the year into two seasons, like summer and winter, and peak hours may be different in each seasons. For example, in BRPL, peak occurs in morning during the winter and in evening during the summer. Let's go to the next slide. So the framework uses mathematical optimization technique to estimate the time of use tariff. The optimization variables are obviously on-peak and off-peak prices. The objective is to minimize the energy purchase cost and capacity upgrade cost, and there are a number of constraints we use in the optimization. For example, the load response itself is governed by the customer behavior, and we model that mathematically, how elastic the customers are and how that would affect the demand change. Also, generation must be equal to the loads. Generator output is limited by their contracted capacity. On-peak price must be higher than your off-peak price, and to make sure that the total customer bill is equal to the energy purchase cost plus the upgrade cost, right? So these are the basic objectives, optimization variables, and constraints we use in the optimization. Let's go to the next slide. So that is about the Effort tool itself. Now, we use this effort tool for the BRPL inputs to estimate what would be a time of use prices for the summer and winter stage. And I'll dive into the results in upcoming slides. Let's go to the next slide. Let's go to the next one. Okay, thanks. Yeah, so NREL results shows by applying the effort tool on the BRPL data shows that the peak reduction can be achieved in both summer and the winter month. An annual peak occurs in the summer month. The top chart shows a profile before and after the TOU for a peak day in a year. The setted region is the on-peak time used in the time of use tariff. Peak reduction seen is in the order of about 2%, which is common with other utility experiences as well. The reason for cost reduction is mainly due to the changes in the generator dispatch from expensive to the least cost generators. Now let's go to the next slide. And this slide summarizes more key results for the summer and winter season. For example, how much is the peak reduction in each season? And you can see we are seeing more reduction on the winter than in the summer, and also the savings as well. These are also, we also highlighted the on-peak hours for different summer for different seasons, and also there are some graphics below for summer and winter season, which is just displaying the load profile during the peak day for both winter and the summer season. Thank you.
Let's get some questions answered here before we move on to the next. So, Mr. Bansal, Honorable CEO, was clarifying a point here, which is very important. But I wanted to ask Killian's view as well on that, which is demand side management, demand response. How similar are they? How different are they? You're on mute, I guess.
Can you hear me?
Yes.
Yeah.
Okay, great. Yeah. So demand side management is an umbrella term for a lot of different strategies, which includes demand response. Demand response is it can be like so under demand side management, people talk about energy efficiency, they talk about distributed generation, they'll talk about controllable and non-controllable, or dispatchable and non-dispatchable forms of demand response. So demand response is a subcategory of demand side management is the way I would think about it. What we're looking at here, to be specific in terms of terminology, is a non-dispatchable form of demand response. So you can't kind of tell customers like, okay, I want you to reduce by a certain amount of megawatts. We're motivating them through price plans.
Thanks. Feel free to ask, clarify, or add more points to it, Mr. Bansal. I'm very happy to hear from you. So let me quickly run through some questions here. The work that we have done is for Delhi, particularly in BRPL. How reusable is this for other states, other consumption patterns in the rest of India? Want to comment on that?
Yeah, I think there's a lot of pieces that can be reused. Like one thing that I would say is a huge strength is we spent a lot of time developing the surveys for this kind of to create this holistic survey for customers in India for both domestic and commercial and industrial. So those surveys, if other utilities wanted to use those to survey their customer base, yep.
I guess it was not intentional. Yeah, go ahead.
Okay. Yeah, so I think that the survey is definitely some piece, and I think if people have, like if utilities understand that their customer bases would be similar to those in BRPL, then maybe the survey results could be directly applicable. I think there was another question. I actually can't see the chat right now in presenter, but I saw something earlier, someone talking about could these results be applicable to all of Delhi? I think likely domestic consumption patterns in BRPL are similar to domestic consumption patterns in other parts of Delhi, maybe for BYPL. So yes, I think that could be applicable. I think the thing you'd want to be more cognizant of is the breakdown of domestic and commercial and industrial customers different. And are there different customer classes or different segments that are unique to different parts of Delhi? I couldn't answer that, but I saw someone saying that the consumption patterns that we're showing for BRPL are quite similar to those for all of Delhi, which makes a lot of sense. So I think then those results could be extrapolated across. And then effort is definitely a reusable framework, as long as other utilities have their consumption profiles and information on generator dispatch and costs. So yes, a lot of these results could be extrapolated to other parts of India, and then the framework and the capabilities that we have could be reused.
Okay, thank you. You're right. So steps here to summarize is effort framework itself can help the user, which is utility in this case, understand the effectiveness of rate structure, correct? And for that, the inputs include the annual load profile for the utility, their costs for generation and energy, and then a survey will help them understand the responsiveness of the customers. So all of them goes inside and helps utility understand. So one quick question I wanted to bring up, I know we are running short on time here, which is I want to speak about the elephant in the room, which is this survey was taken during COVID, which means everybody are working from home, whereas the future is uncertain. So how can we comment on the changing times that we are in now?
Yeah, there were elements in the survey where we asked about occupancy patterns pre and before COVID and during COVID. And so we do have information on that piece in terms of, how many people were basically at home before COVID versus during. I think that there's uncertainty in both forms there, because there's also uncertainty of what the future work is going to look like. How many people are going to continue remote working from home? What is the patterns going to be in the future? But I think the important part from the survey is people's willingness and people's alertness, and that they are, that they want to participate in these kind of measures and that they want to respond, because I think that information is useful. And, if people are at home, they're probably going to be more likely to be able to respond to this versus if they're in work. So I think there's also a little bit of, well, not a lot, there's a lot of uncertainty in terms of what are consumption patterns going to be going forward. I don't think it's clear that they're going to be what they were before COVID, and I don't think it's going to be the same as what they were like during COVID. So I think there's a lot of uncertainties for utilities the world over in terms of what consumption patterns are going to be like. But unlocking demand side flexibility and trying to motivate customers to get more information on how they can respond, I think that's a positive either way.
Thank you. We have many questions. I recommend we pull these questions and respond to them again in some way. Some very interesting questions are being posted in chat as well as the question and answer section. For now, let's continue with the slide deck. There are some very interesting one slide or two slides here that I would recommend you all listen to, and then we can see how can we answer these questions.
Okay, great. Thanks, Sudarshan, and really great questions. I'm sorry I can't see them, but thank you for pulling them up. And great to hear everyone really engaging, and these are really insightful questions. So definitely looking forward to going through more of these later. So yeah, to recap from what Kapil was presenting, essentially we came up with this summer on peak time period and a winter on peak time period, and we're seeing this kind of potential response that the utility could get in terms of reducing peak demand, and the benefits there are many, right? The benefits are in reducing your actual peak demand, which reduces the amount of the network capacity that you might need going forward. So it can defer asset upgrades. It also reduces the amount of peaking generation that you have to use to supply demand, which should bring down electricity prices. Which I think the last time we presented this, there's questions on why did we have an on-peak period during winter when clearly the system peak during summer is so much higher than winter. So the answer there is not really in terms of the total capacity, it's really on peaking generation. That you're, even in winter with the shape of that load profile, the peak period in winter, trying to move consumption away from that peak can save you in terms of using more expensive peaking generation in winter. So to go forward, like what we were looking at here was this kind of this step in terms of looking at time use tariffs to start getting responsiveness from customers. And we did go into a lot more detail in terms of looking at what future price plans BRPL could consider, and these are being considered by and implemented by utilities across the world. And really the benefits of looking at more advanced retail rate structures and getting that responsiveness from customers are fourfold. The kind of one that we've been talking about a little bit here is energy efficiency, in terms of motivating customers to reduce their consumption and purchase more energy efficient loads and appliances. And so they are getting that benefit in terms of, if I reduce my consumption, what kind of benefits do I get in terms of my bill, and making people aware of that. The other side is this demand reduction and load leveling, so reducing that peak consumption and motivating customers to shift their energy away from the on-peak to the off-peak period. So really those first two relate to energy and they relate to capacity. These last two are kind of more on the emerging DER side. As you move to more advanced retail rate structures, and say if you start looking at net energy metering is usually a next step, is you start to motivating customers to purchase behind the meter distributed energy resources and generation, particularly rooftop solar is what we see here. And that can reduce, say, grid imports for discoms from the bulk system. But then, you know, trying to motivate solar, usually what utilities then find is that they need to try find an equitable way of doing that, and try find a way that, you know, they are still recovering a lot of their fixed costs. And that's where, moving away from net energy metering, you can go to feed-in tariffs, you can go to zero export tariffs, you can go to demand charges, and those kind of more even further down the line rate structures start to motivate customers both to do increased levels of demand response, but also to start using DER storage, so such as behind the meter battery systems, such as lithium-ion, that we're seeing starting to come into the market, and customers starting to adopt those. So, you know, looking forward is really important in terms of your retail rate structures. It's, you know, time use is one step along the way of developing these more advanced rate structures that can help deal with DER generation, DER storage, and demand leveling and energy efficiency. So to recap the overall project outcomes, this is a really great collaborative effort, and I'd like to thank, I can't thank everyone enough on this one in terms of all of the effort and all of the information and all of the meetings that we had with BRPL and the G2G RISE team. And it was only because of this really great team that we were able to get such great results and get such great information. And we were able to look at how to unlock the demand side management potential. We created this reasonable effort framework effort, a tool that discoms can use to look at rate structures. And we investigated that sensitivity of on-peak duration and customer response, and looked at the potential to reduce peak demands. And we got a lot of information on the voice of the customer, which is so crucial and so important for demand side management, to understand what are your customer characteristics, and getting the survey information and getting all of these kind of 90 different questions on everything from their consumption patterns, their appliance ownership, to, you know, how they would respond to different DSM mechanisms. And then, you know, to be able to survey during COVID over 400 residential and over 300 commercial customers just speaks to what a great team we had here to be able to get all that information during definitely a difficult year. So again, kudos to everyone, and thank you so much to all the team. Adarsh, I'll hand it over to you.
Thank you. We have many questions here. I really appreciate all the thoughts here. We will find a way to get back to you as an answer. I'll work with Repo on that feasibility for that. So here we are on top of the time here. I will I want to thank everybody here for listening to all of us and taking time to share your thoughts and your suggestions and recommendations and your questions. With that, Monali, what should we? I'll back to you. Do it back to you for now.
Sure, we had you for the vote of thanks as well, others. So maybe we can, first of all, we can try respond back to the question and circulate it as a part of, our proceedings. So that is one way we can address many questions and comments which have come in. But over to you for the vote of thanks.
Thank you. I kind of wrote up this nice thing as well. Like I was honored to hear from Mr. Sinha, Mr. Bansal, their thought. It's running a distribution utility is becoming more and more complex, if anything. It's as the content we saw here, layering demand side management, demand response on top of solar, top of storage, and lo and behold, we have to address electric vehicle. It's whole another beast that needs to be addressed about rate structures. So the future is going to be very interesting. I'm curious to see how, as progressive as a utility structure in BSES and the leadership team in BRPL and BSES in general, how are they going to embrace, and we are very glad to be a part of the journey. To summarize, this effort or this work together really helped us understand the groundwork in India, the readiness of the customers to participate in demand side management, demand response, the best way possible. There is a need for technology to enable that, and we are very glad that we were a part of this journey to start with. A big thanks to GTG RISE team for working with us, helping us understand the way how can we model the response of Indian consumers to start with. And let me also go and thank USAID. Heartfelt thanks to USAID here. Without them, we could not even have been a part of this effort. Sure, I mean, such a sad thing. I'm so glad that we are part of this. And thanks, Karen, for setting up the context. We appreciate that. And here, all in all, it's been a great journey. From beginning to end, we have made 3 public reports available. We are calling all of the reports Preparing Distribution Utilities for the Future. And then there are 3 subcomponents that we have gone in detail to. The very first study focused on energy storage, solar and voltage in a distribution utility. Second report focused on load evolution, as all these new technologies that get piled up on each other. How do utilities have to embrace these changes and expect their load shape to change? And this is the third study that we did, which is focused on demand side management. The entire journey on this effort has been fantastic. Big thanks to BSES leadership, which Mr. Sinha currently represents. A big thanks to Mr. Sinha, and Mr. Bansal here has been very supportive on all this. Thank you.
Thank you so much, Adarsh and Dr. Killian, Jayanta, and Kapil for the great presentation. There were lots of questions. Unfortunately, we are not able to get to all of them, but we will try and circulate the responses via proceeding. Before we conclude, I would also like to take the opportunity to thank the presenters, especially NREL team, for making a great presentation. But before that, our partners, BRPL and BYPL, BRPL, and the entire BSES group, as mentioned by Adarsh, we managed to come out with 3 reports under greening the grid in partnership with BSES, and each of them, really relevant teams. So thank you so much, specifically to Abhishek for being very proactive and taking a lead in this, and also to Mr. Sinha and Mr. Bansal for their leadership. And thanks to our GTG RISE team for, being always helpful in terms of facilitating these discussions and meeting and supporting these studies as required. And thanks once again to all the participants who joined today. It's way, I mean, we are over the time, and it's quite late in India, so really appreciate your interest. And we look forward to continuing and at least talking a little more on the tool. We'll look for other forums and opportunities to do further outreach on this particular tool. And thanks so much for joining, everybody, and have a good night here in India and a good day to all the colleagues joining from US. Thank you so much.
Thank you, everyone. Thank you.
Thank you. Thank you.
Great. Thank you.
Take care. Thank you.
Hey, Ripu, is there a way we can get these questions exported?
Oh, I did that, Adarsh. I have them there.
Did that?
Sure.
Okay.
Yeah.
There is a way. There is a way. I'll get those in.
Somebody also asked for the link of the tool. So maybe we can include that also as a part of the package.
I saw that question as well. Yeah, there were some very interesting questions. Appreciate all the support here. Thank you. Okay, then. Let's get back with the questions and let's get it answered. Let's stay in touch on close on this.
Great, thank you so much. Lots of questions, great interactions, and I think with goof ups on my side, I don't know why so many internet issues today. But thank you all. Thank you so much.
No,
It's the way. Yeah.
See you guys soon. Yeah. Thank you. Bye.
Thanks.
Great. Thanks so much. Take care. Bye bye.
Bye.